Welcome to Math Simplified. This video is for 10th standard students. Please subscribe and share with your friends. Today we are starting the second chapter, Numbers and Sequences. Euclid's division lemma. Let a and b be any two integers, then there exists unique integers q and r such that a is equal to bq plus r, where 0 is less than or equal to r is less than b. Okay, let's try to understand this with a simple example. Here I am going to take a as 17, b as 3. Okay, so this is called the dividend and this is the divisor. I am going to do a simple division. I get the quotient 5 and the remainder 2. Okay, so what the lemma says is I can express 17 in this way. 17 is equal to divisor into quotient plus remainder. 3 into 5 plus r. See, a is equal to b, that is the divisor, into quotient plus r. Supposing the remainder is 0, then this becomes a is equal to bq, that is b divides a. Next is Euclid's division algorithm. This is used to find the HCF of two numbers, like example 273 and 119. Here we are going to use the lemma. We are going to write this. I take this as a and this as b. So a is the dividend, 273, b is the divisor, 119. Find out the q and r. Since r is not equal to 0, again this divisor will become the dividend, remainder will become the divisor. Again find the q and r. So you continue this till the remainder is 0 and the divisor becomes the HCF. We will do many sums on this, it will become very clear then. Okay, let's go to the exercise. Question 1. Find all positive integers which when divided by 3 leaves a remainder 2. Okay, so we are dividing by 3. That means 3 is the divisor and remainder r is 2. Let's write down the lemma. A is equal to 3q plus 2. So here the question is we have to find all positive integers which are divided by 3. That means we have to find all the values of a. So in this lemma, put q is equal to 0. What do you get? A is equal to 2. Put q is equal to 1. You get a is equal to 5. Q is equal to 2. A is equal to 8. So forth. So the answer is the integers are 2, 5, 8, 11 ... which when divided by 3 will leave a remainder 2. Question 2. A man has 532 flower pots. He wants to arrange them in rows such that each row contains 21 flower pots. Find the number of completed rows and how many flower pots are left over. Okay, so here this is the dividend, 532, that is A, and 21 is the divisor, that is B. So write down the Euclid's lemma. 532 is equal to 21q plus r. Now do the division and find the values of q and r. You will get 25 and 7 as the remainder. So the number of completed rows are 25 and how many flower pots are left over? The leftover flower pots are 7. Question 3. Prove that the product of two consecutive positive integers is divisible by 2. Let n minus 1 and n be two integers. Then the product is n into n minus 1 is equal to n square minus n. So consecutive integers we have taken and we have multiplied them and you get this. Okay. Now general form for any positive integer is 2q or 2q plus 1 for some positive integer q. So any integer can be written in these two forms. This is the general form. Okay. Now supposing n is equal to 2q. Let's write down n is equal to 2q. Put it here. N square minus n. So what do you get? You get this value and you can take out 2 common. So you have 2q square minus q in the bracket. So this expression is definitely divisible by 2. Okay. Let's put n is equal to 2q plus 1. This is the other possibility that n can be 2q plus 1. So n square minus n is again you solve it and you will get the expression as 2 into 2q square plus q. So here again this expression is divisible by 2. Hence n square minus n is divisible by 2 for every positive integer. Question 4. When the positive integers a, b, c are divided by 13, the respective remainders are 9, 7, 10. Show that a plus b plus c is divisible by 13. Okay, first let's write down the lemmas. So let the positive integers be a, b, c. So a is equal to 13. It's divided by 13. So 13 is the divisor. We do not know the quotient, but we know the remainder. Remainder is 9. So a is equal to 13q plus 9. B is equal to 13q plus 7. C is equal to 13q plus 10. So these are the three lemmas you got. Now we need to add them up. A plus B plus C. Add up the right hand side. So then, now solve this. Simplify it. You will get 39q plus 26. So take 13 as a common factor. In the bracket you will have 3q plus 2. So this expression is divisible by 13. So a plus b plus c is divisible by 13. Question 5. Prove that square of any integer leaves the remainder 0 or 1 when divided by 4. Let the integer be x, the square is x square. Let x be an even integer. So it will be in this form because it's even. X is equal to 2k. So x square is 4k square. We can write this as 4q plus 0. Q is equal to k square. So x square is divisible by 4 and leaves the remainder 0. So here, supposing we take x as an odd integer, x is equal to 2k plus 1. So x square is equal to 2k plus 1 whole square. Open the brackets, you will get 4q plus 1, where q is equal to k into k plus 1. So here it is in this form. This means that it leaves a remainder 1. Here it leaves a remainder 0. So x square leaves a remainder 1 or 0. See here, if it is even, it will be 0. So in this case it's odd, so it's leaving a remainder 1 when divided by 4. So we have, for every even integer it will leave a remainder 0. For every odd integer it will leave a remainder 1. So the square of any integer leaves the remainder 0 or 1 when divided by 4. Number 6. Use Euclid's division algorithm to find the highest common factor, 340 and 412. So let's take these two numbers. So we are going to find the HCF in a very easy method. We don't need to factorize any numbers. Just follow this method. So here take the bigger number, take it as A, and this number as B. Write down the lemma for it. A is equal to, that is 412 is equal to 340 into the quotient plus remainder. You have to do the division. Then you will get the quotient and the remainder. Ordinary division. So write down like A is equal to BQ plus R. So the next step, because the R is not equal to 0, we are again going to continue writing the lemmas. So in this case, the next step, this B will become A. That is, the divisor will become the dividend and the remainder will become the divisor. Okay. So here we have this dividend and divisor. Do the division, you will get the quotient and remainder. Okay. Now the next, still it is not equal to 0. So next step, again you will take this divisor as the dividend and this remainder as the divisor. And continue doing the division till you get the remainder as 0. So here it is. When you divide 8 by 4, you get the remainder 0. Okay. So this divisor 4 is the HCF of these two numbers. Okay. So second sum, find the HCF of 867 and 255. Okay, let's do it. So which is the bigger number? Write it as A, write 255 as B. Do the division, you will get quotient Q and remainder 102. Okay, next step, take this divisor as the A, that is the dividend, and take remainder as the divisor. Again do the division, you will get the quotient Q and remainder 51. Okay. Now still it's not equal to 0. So take this as the dividend, divide it by 51, you will get the quotient, and now the remainder is 0. So now the divisor be careful here, don't take the quotient, it should be always the divisor. 51 is the HCF. Okay, next numbers, 10,224 and 9,648. So write down the bigger number as A and this as B. So do the division, you will get the quotient and remainder. Okay, now take this as A and the remainder as B and do the division, you will get the quotient and remainder. Still it's not equal to 0, so take this number as the A or the dividend and take this remainder as the quotient, divisor, and do the division, you will get the quotient and remainder. Again it's not equal to 0. Again this number becomes the dividend and the remainder becomes the divisor, and divide it, you will get Q as the 3 as the quotient and 0 as the remainder. So this divisor 144 becomes the HCF of these two numbers. Okay, now here there are 3 numbers and we have to find the HCF of all 3. Okay, so for what we are going to do is, first we will find the HCF of these two numbers, then the answer that number and this number will find the HCF. So the final answer will be the HCF of those two numbers. Okay, let's take 84 and 90. 90 is bigger, so 90 is A. 90 is equal to 84 into 1 plus 6. Okay, so again take 84 as A and 6 as the divisor B. Do the division, you will get quotient Q 14 and 0. So here the HCF will be 6. Be very careful, do not confuse with the quotient. You are dividing by 6, so 6 is the HCF. Okay, the divisor only becomes the HCF. Okay, so now what happens? You have to find the HCF of 6 and 120. Okay, so bigger number is 120. 120 you divide it by 6, you get the quotient as 20 and remainder as 0. So here the divisor 6 is the HCF of 6 and 120. So 6 is the HCF of all these 3 numbers. Question 7. Find the largest number which divides 1230 and 1926, leaving the remainder 12 in each case. So here there is a remainder 12. So first what we are going to do is we are going to subtract this remainder and we'll find that number. So subtract the remainders, and so these are the two numbers, and now we'll do the HCF of these two numbers. Okay, use the division algorithm, write down the lemmas, and when the remainder becomes 0, the divisor is the HCF. So that is the largest number which divides 1230 and 1926 and leaves the remainder 12. Question 8. If D is the common factor of 32 and 60, find X and Y satisfying this equation. So D is the common factor of 60 and 34. Let's find out the HCF. What is the value of D? So first write this, the bigger number 60 is equal to 32. That's a divisor. Divide 32 by 60. You will get quotient 1 and the remainder 28. Again 32 you write here, 28 divided by 28. You will get the remainder 4. Again 28 write, divide by 4, you will get the remainder 0 and the quotient 7. So okay, so this divisor 4 is the HCF. So that is equal to D. Okay, so D is the common factor. So we found out D. Now we have to find out the values of X and Y. So let's take this equation. 32 is equal to 28 into 1 plus 4. So 4 is equal to what? 32 minus 28. Okay. So this is equal to 30. Now substitute 28 from here. 28 is equal to 60 minus 32. 60 minus 32. Open the bracket. You will get 32 minus 60 plus 32. This is equal to 4. So why are we doing all these steps? We want to bring this in the form 4 is equal to 32x plus 60y. That is why we are doing these steps. So 32 plus 32 is 32 into 2. Okay, and minus 60, and minus 60 also will write it like this, 32 into 2 plus brackets minus 1 into 60. So it will look like this. See, we can compare with these two. So 4, we found out that 4 is equal to 32 into 2 plus minus 1 into 60. And comparing with this given equation, we find that x is equal to 2 and y is equal to minus 1. Question 9. A positive integer when divided by 88 gives the remainder 61. What will be the remainder when the same is divided by 11? So when it's divided by 88, this is the lemma. Now we are going to divide it by 11. So this expression, when you divide, you have to divide the remainder only. So if you remainder, because this is already a multiple of 11, 88. Okay. Anyway, dividing this remainder by 11, you will get, you can write it as this lemma, 61 is equal to 11 into 5 plus 6. So what is the remainder? 6. That's what they are asking. What will be the remainder when the same is divided by 11? Question 10. Prove that two consecutive positive integers are always co-prime. So integers are co-prime if the only positive integer that divides both is 1. So two integers can be said to be co-prime if the common factor is only 1. Okay. Let x be all positive integers. Consider any two consecutive integer. So when one is even, the other is odd. Okay. So if supposing this is the number, the next number will be x plus 1. So if it's an odd number, the next number is even. If the number is even, the next number is odd. And the HCF of this kind of odd and even number is always 1. So only 1 divides the consecutive integers. Hence the two consecutive positive integers are co-prime. So here we come to the end of exercise.